Okay, so let's find all the zeros of p of x, write p of x in factored form, and then sketch the graph of p of x. So first, we know that the degree is 6. Okay, so let's write it here. Degree is 6. So therefore, we're going to look for 6 zeros. Now, if we look at the sign changes, positive, the first term is positive, the second term is negative, third term is negative, fourth is positive, next term is positive, this term is negative, and the last term is negative. Okay, from positive to negative is one change, negative to negative, no change, negative to positive, one change, positive to positive, didn't change, positive to negative, another change, and then negative to negative, no change. So there's a total of 1, 2, 3 sign changes. So there are 3 sign changes. The number of sign changes is equal to the number of positive zeros. So therefore, we expect to see 3 positive zeros. And therefore, since there are 6 zeros altogether, 3 are positive, the other 3 can only be negatives. So 3 negative zeros. So we have even number of positive and negative zeros. Okay, again, there are 3 positive zeros because there are 3 sign changes. If there's only 2 sign changes, then there's only 2 positive zeros. Okay, so let's erase this now. Okay, so now we know that we have to look for 6 zeros. 3 of them should be positive and 3 of them should be negative. Now we want to find out what are the possible zeros so that we can pick from a list of possible zeros. So we are going to need here the factors of the constant term, which is 4, over we need the factors of the leading coefficient, which is 3. So we're going to need the factors of 3. Okay. So let's list. Factors of 4 are 1, 2, and 4, while the factors of 3 are 1 and 3. So to generate our list, we will have positive and negative of. So we divide 1 over 1 is 1. That's why we call this a ratio, because that's a fraction. 1 over 1, that's a ratio. 2 over 1 is 2. 4 over 1 is 4. Now 1 over 3 is 1/3. And 2 over 3 is 2/3. Now 4 over 3 is 4/3. So that means we have this many numbers to choose from. We take the positives and the negatives of this and see if these, which one of these are the zeros of this polynomial function. Okay, so let's start the search. So to start the search, we have to get the coefficients of our polynomial p of x. But first, take a look at the exponents. Highest is 6. It's followed by 5, and then 4, 3, 2, 1, and then 0. So again, we don't need to put a 0 somewhere because all of the exponents from 6 down to 0 are represented here. So coefficient of x to the 6th is 3. Of x to the 5th is negative 2. Of x to the 4th is negative 16. Of x cubed, it's positive 10. Of x squared, it's 17. For x, it's negative 8. And our constant term is negative 4. So let's try. Of course, we want to try 1 first. Okay. So is 1 a 0? So we bring down 3. 3 times 1 is 3. Negative 2 plus 3 is 1. 1 times 1 is 1. Negative 16 plus 1 is negative 15. Negative 15 times 1 is negative 15. 10 minus 15 is negative 5. Negative 5 times 1 is negative 5. 17 minus 5 is 12. 12 times 1 is 12. Negative 8 plus 12 is 4. 4 times 1 is 4. And we notice that we get here a 0. Great, 1 is a 0. Now, let's try if 1 is a 0 again. So once we found a 0, find out if it's a double 0 or a triple 0 or a quadruple 0. So we have to test it until it stops being a 0 of the function. So we bring down 3. 3 times 1 is 3. 1 plus 3 is 4. 4 times 1 is 4. Negative 15 over 4 is, no, negative 15 plus 4 is negative 11. Negative 11 times 1 is negative 11. Negative 5 minus 11 is negative 16. Negative 16 times 1 is negative 16. 12 minus 16 is negative 4. Negative 4 times 1 is negative 4. Oops, we found another 0. So it turns out that 1 is a double 0. Now let's see if it's a triple 0. If we can make it a triple 0. Is it a triple 0? If it doesn't work, then we erase and find another 0. So we bring down 3. 3 times 1 is 3. 4 plus 3 is 7. 7 times 1 is 7. Negative 11 plus 7 is negative 4. Negative 4 times 1 is negative 4. This is going to give us negative 20. Negative 20 times 1 is negative 20, and it's not going to make a 0 with the negative 4. So that means negative 1, positive 1 is not a 0 3 times, but it is a 0 2 times. So it's a double 0. So we're done testing 1. We now go to negative 1. Okay, so after testing if 1 is a 0, if it doesn't work anymore, then try negative 1. So we bring down 3. So 3 times negative 1 is negative 3. 4 minus 3 is 1. 1 times negative 1 is negative 1. Negative 11 minus 1 is negative 12. Negative 12 times negative 1 is positive 12. Negative 16 plus 12 is negative 4. Negative 4 times negative 1 is positive 4. And we have opposites here, and therefore we get a 0. Okay. So we found our 3 zeros. Now, is negative 1 a double 0? Why don't you try it and see if it's a double 0? You can pause this video and try it. Okay, so it turns out that negative 1 is not a 0 2 times. So it's just a 0 1 time. So now we're going to try and do another, or test another number from our list. So the first number that we tested was 1, and then negative 1, now 2, and then negative 2, and then we go on with the list. So let's do 2 here. I don't have space, so maybe I could just insert it here. So 2. Okay. So we bring down the 3. 3 times 2 is 6. 1 plus 6 is 7. 7 times 2 is 14. Negative 12 plus 14 is 2. 2 times 2 is positive 4. And we got another 0. So far we have found 4 zeros. 3 of them are positives. So that means we have found all the positive zeros. We just need now to find 2 more negative zeros. So let me bring over our result, our last row of numbers. So we have 3, 7, 2. So 3, 7, 2. These are our last row. We could put the 0, but we don't really have to. So now let's try, is 2 going to work? If I try positive 2, if I bring this down, multiply by 2, I'm going to have a big number. And then add to 7, that's an even bigger number. This is 2. I need to get a negative 2 here. And there's no way for me to get a negative 2. So that means 2 is not a double 0. So let's try negative 2 this time. Okay, so let's do that. So we bring down 3. 3 times negative 2 is negative 6. 7 minus 6 is 1. And 1 times negative 2 is 2. And we found our next 0. All right, so now we have 1, 2, 3, 4, 5 zeros. Okay, and therefore our last 0 is right here. This is only 1, 2, 3 numbers where the last one is a 0. So this is our last linear factor. So we can take this, make it the coefficient of x, plus 1, plus this number here, equals 0. Then we solve for x. So we know that we have to take away 1 from both sides. And therefore, we'll have 3x equals negative 1. And so x is equal to negative 1/3 because we're going to divide both sides by 3. All right, so we have 1, 2, 3, 4, 5 zeros that are integers. You can make them look like a whole number. They are whole numbers. So those are integers. And then 1 0 is a fraction. This is called a rational number. Okay, so but not an integer. So all of these numbers could be turned into a ratio or a fraction, but not all of them could be considered integers. So these are the only integers in this list. And so therefore these are the integer zeros, and this is a fractional 0 or a rational 0. All of them are rational zeros, but this is not an integer. These 5 guys are integers. Okay, so let's write p of x as a in factored form. So we'll have here okay, let's list first the zeros. Okay, so we list the zeros. Okay, and these are the zeros that we found: 1, 1, negative 1, 2, and negative 2. Notice that if we count this 1, 2, 3, 4, 5, where's the other one? Oh, and the last one is negative 1/3. Okay, so now we can write p of x in factored form. So p of x is equal to parentheses. So if the 1 is the 0, the factor is x minus 1. X minus the 0 times x minus 1, or x minus 1 squared. Okay, for the next one, it will be x minus negative 1. But x minus negative 1 is the same as x plus 1. And for this, the corresponding factor is x minus 2. And for this one, the factor is x plus 2. 1, 2, 3, 4, 5. Now for the last factor, instead of taking x minus negative 1/3, we can just take this 3x plus 1. This came from this. So we'll just write down 3x plus 1 here. Okay. Now to graph. So let us graph. So maybe let's graph over here. Okay, so in order to graph, let's find first, so we got the zeros here. Now we need the y-intercept. And the y-intercept is p of 0. So you can either plug in the zeros into this factored form, or you can plug it in the standard form, which is right here. So if I'm plugging in 0 in all of the x's here, this becomes 0 to the 6th, which is 0 times 3 is 0. Any number multiplied to 0 becomes 0, right? So all of these will be 0. 0, 0, 0, 0, 0, 0, because it's going to be negative 8 times 0. So therefore, the only thing left is negative 4. So 0 minus 4 is negative 4. That's our y-intercept. So we're going to put here y-intercept, or p of 0, p of 0 is equal to negative 4. All right, so now let's do the graph here below. So our axis, so x-axis, y-axis. Okay, so okay, 1, 2, 3, 4. 1, 2, 3, 4. So let's put here 1. Okay, so when you're graphing, I want you to scale. So put the scale. So here, maybe we can go by ones here because the y-intercept is only 4. So 1, 2, 3, 4. Negative 1, negative 2, negative 3, and negative 4. Okay, so let's put all the important points. Important points are at 1. So there's 1 here. Then at 2. At negative 1. At negative 2. And there's 1 and 1/3. Negative 1/3, so it's right here. Okay, so let's graph. Oh, we need the y-intercept. The y-intercept is negative 4, so let's mark this point here, negative 4. And so the graph is, okay, it's going to touch 1, and 1 is a double 0. So we're gonna go to 1, touch 1, and then bounce. And then it will come down, but then go back up to touch 2, and then it will just keep going up because there's no more x-intercept on the right side of 2. Now, the next destination for this is the negative 1/3. Okay, so that's gonna be, we're gonna go there. Okay, I should have made this like wider. And then it's gonna cross here because it's not a double 0, and then come back, and then cross again because it's not a double 0, it's just a single 0, and then come back for the negative 2, and they'll just keep going up because there's no more x-intercept on the left side of negative 2. And that's the graph.